Hi, my name's M.Randall. I'm a Senior Project Officer with the Queensland Government here in Australia, and I'm going to be talking today just about the Australian national guidelines that we are in the process of introducing for image velocimetry and surface radars. So the background of my talk will be to give a bit of background about Australian water monitoring, how we got to the situation where we're at, where we require the guidelines, and then further bit of information regarding the guideline development and the document itself. So starting with the background and Australia and surface velocity. And in Australia, surface velocity work was pretty limited to fixed radar systems predominantly used in the southern states. So for example, Tasmania, Snowy Hydro, which is in New South Wales, Victoria. Here in Queensland, traditionally we have not used radar systems, primarily due to the remoteness of the sites and lack of bridges and infrastructure to install them on. We did have occasional use of surface velocity measurements, mainly timing of debris, floats, and also current meters using them from a boat. But primarily since the 2000s, we've been ADCP dominant for flood flows and increasingly lower flows. So in 2016, we in Queensland established the Alternate Technologies Project, which was involved establishing primarily image velocimetry sites, and the idea was to validate image velocimetry software and methods. We looked at LSPIV techniques and STIV techniques. And we really wanted to validate those methods, which included the use of drones, and validate the data against more traditional methods. Also importantly, we wanted to make sure that those methods could be incorporated into a quality management system under the ISO 9001 accreditation that we have. So some of the project drivers, obviously, first up was workplace health and safety. A lot of pressure on not undertaking high flow measurements due to safety reasons, putting people in boats. So this was seen as an opportunity to find an alternative to those methods. Improved data collection capabilities. So, for example, remote sites, and also with that ability to collect those flows that you couldn't measure with ADCPs. Minimal staff puts pressure on being able to collect traditional boat measurements with time and the ability to collect more measurements at a site. And of course, there's also improved economics that image velocimetry was able to offer us. So, for example, the Q-boat there, plus an ADCP and some section-by-section software, generally costs in the region of 160,000 Australian dollars. Requires 2 members of staff at least to operate the equipment, to collect a measurement, and of course you've got to be able to access the site. In comparison with what we were able to do with image velocimetry is, for the same money, we were able to purchase commercial image velocimetry software, purchase a number of various different cameras, including far infrared cameras, and we were able to throw in drones, including RTK drones, and the software to develop digital elevation models with that, and also start working on on-site automated processing. So in terms of finances, the whole image velocity really could expand the amount of sites and the type of sites that we could measure for the same amount of money. This is an example of one of those sites, remote area we're not able to access and provide flow measurements for lower flows and higher flows at the same site when we couldn't get there. And when you're able to collect numerous measurements over the course of some events, you're really able to to build up your rating curve, and compared with our traditional measurements, typically on the receding limb, the data that we were getting we were pretty pleased with, especially when it compares very nicely to ADTP gaugings. Our project concluded in 2018, and at the end of that we adopted image velocimetry as a standard method of monitoring discharge for the Queensland government. And at that time we were receiving increased interest from other organisations in Australia and outside of Australia, looking for training and at workshop attendance to be able to start implementing the methods that we had been testing and trialling. So with that increased national interest in applying these methods, we then, in communication with the other states, decided to start working on a national guideline. So why do we need a national guideline for surface velocity? Well, as I've mentioned already, there's the rapidly developing interest in these methods, but also there's a varying level of programs available to undertake the analysis, so from commercial software to open source software, and as well as research-based projects and applications. So having a guideline enables consistency in the application and processing of these methods, increases the ability to have the methodologies operationalised and accepted within water monitoring, and of course provide confidence in the data and the methods that are being applied. In Australia, we have 6 state governments as well as 2 territories. So traditionally each of these agencies and organisations had their own standard operating procedures, and for collecting flow measurements there wasn't a standardised approach between many of the organisations even within each of those states. We have the federal government, which has the Australian Bureau of Meteorology, and under the Water Act here the Bureau is responsible for collecting all the information from all the different states and organisations and providing that information to outside bodies. So they're really in charge of looking after all the information that we're collecting. And in 2014, the Water Monitoring Standardisation Technical Committee, or WAMSTEC, was established, and this was a nationally representative committee. The idea at that time was to coordinate development, endorsement and adoption of national guidelines that all the state governments and the agencies within the governments would operate by, allowing data between states to be able to be compared in terms of quality and methodology. So all of the work undertaken with WAMSTEC is voluntary from the members. So there is an endorsement process for the production of guideline documents, and the surface velocity guidelines that we're currently working on has just finished number 3, the industry consultation. The next step will be for endorsement and publication. So this is the document that we've just undergone consultation, and as you can see we've tried to cover most or all of the main parts of image velocimetry, as well as including surface velocity radars as information on coefficients and how to turn those surface velocities into discharge. The main point when we put the document together was to try and align with existing documentation that was already out there. So for example, ISO 748 it has a number of recommendations regarding things such as exposure time, the number of verticals used in discharge calculation, as well as information for site selection and conditions. So we wanted to align with existing and accepted ISO documents that are out there. And as I said, with the document, we wanted to provide as much detailed information as we could to create awareness in the users who wouldn't be familiar with these techniques to be able to apply them successfully. So we concentrated on LSPIV and STIV image velocimetry techniques, including fixed cameras and drones. And that includes information and guidelines on interrogation, search areas, frame rates, filters, and for STIV searchline placements, cross-section management and placements, and also highlighting where errors in the process could occur. For radar systems, we looked at fixed mountings as well as handheld radars, including site selection and then also surface coefficients, surface alpha, and determination of how to come up with those values. Exposure time was one that was particularly received a particular amount of feedback from the review, and suggested times given to us were from 4 to 40 plus seconds. However, for the document, ISO 748 already has a recommendation exposure time of 20 seconds for float, so we have decided to align ourselves with that for the time being, with a recommendation of longer. Multiple measurements have been allowed to meet or exceed the exposure time requirements. So, for example, a number of short videos could be collected and then the results averaged to provide a discharge value. For radar systems, we remain with the 40 plus seconds for exposure time, depending on the site. Ground control points and author rectification. We have introduced, or wanted to introduce, a quality assessment for that, and there is an international standard out there concentrating on photogrammetry and using the root mean square to calculate the horizontal accuracy. So we provided guidance on using this this methodology to really gain some sort of quality of how the author rectification process has taken place. Each area with the root mean squared is a circular area around each ground control point, so we provided information and guidance on that. This is just an example of that data that provided in one of the software for the rectification, and you can see the errors there on the right, top right. So again, it's about highlighting where these errors have occurred and how to minimise them as we can. The example of this international standard there, so the recommendations are basically that after you finish the rectification, whatever your final scaling value is there, that the RMSE is minimum of 2 times the pixel size, or an error of 2 pixels. So that's a recommendation for standing mapping and GIS work. So precisely what we're doing with image velocimetry and using the pixels to measure distances. Another thing that we're looking to introduce is some guidance around data interpolation and estimation, and considering limits to define the measurement quality based on how much data has been estimated rather than actually measured, and the reporting of the percentage of each of those to allow a decision to be made on the quality of the measurement. So the timeline for the document development, well, June the 8th this year is when the revised draft will be submitted back to the WAMSTEC, where a vote for endorsement will take place, and publication will then hopefully take place in August, September this year, and at that point all of the surface velocity data in Australia will be expected to be collected in compliance with the guidelines. So thank you.